Hello and welcome. I'm Kate Malash, your host for this episode of the Poultry Podcast Show. Joining us today is our guest, Dr. Adam Fahrenholz, who is an associate professor in the Prestige Department of Poultry Science at North Carolina State University. Go Pack. That's for a few of our audience members. You know who you are. His focus for research is in the areas of feed manufacturing, technology, regulatory compliance, and the feed manufacturing process management. Dr. Fahrenholz coordinates the feed milling program, which incorporates an undergraduate minor and both undergraduate and graduate certificates. He teaches courses on feed milling technology, quality assurance, and facility and process management. He also oversees the operation of the NC State Feed Mill Education Unit and its academic, research, and extension missions. Additionally, Dr. Fahrenholz serves as an industry consultant and coordinates an extension program focusing on industry education, the provision of resources for developing programs associated with regulatory compliance, and addressing continuous quality and process improvement in feed manufacturing facilities. Welcome, Dr. Fahrenholz. How are you doing?
Hey, Kate. I'm doing great. Thanks for having me.
Great. I hope your fall semester is off to a good start.
So far so good. Everybody's getting into the swing of things. We've got a couple weeks under our belts now. So everyone's kind of figured out where or when their classes are and has switched what they need to and all that. So we're off to a good start so far.
Very exciting. Well, before we jump into our topics for discussion today, can you tell us a little bit more about your background and how you came to be at North Carolina State University?
Sure. Yeah. So I ended up doing my undergraduate at Kansas State University in the degree at the time was called Feed Science and Management. Basically, I had some family involvement in the feed industry. My father worked in the pharmaceutical side of animal food for many years, and I actually grew up around Kansas State. He and my mother were going through school at the time when I was born, so right there in Manhattan. And I ended up going back there, both probably somewhat because of the familiarity there and the kind of, it's a nature versus nurture question to some extent. But I had a lot of interest growing up. Grew up on horse farms, always around agriculture from that perspective. I liked engineering kind of things, and I liked some physiology and nutrition and chemistry, but I wasn't going to be. I didn't want to be a mechanical engineer, and I wasn't going to go be a nutrition focus or something in medicine or something like that. And so the going the feed milling route made a lot of sense because I got to play with equipment, but also had to understand the chemistry of what we were doing and the biology of the animals we were feeding, and all those things came together, and it made a lot of sense. So I went there for my undergrad, and I liked it enough that I stayed and did 2 more degrees with Keith Benke. Who was my advisor, kind of going all through that process. So I did my master's and my PhD. When I finished up my PhD, one of the things that I knew was at K-State, we did a lot of focus, especially at that time, on the things that would be mostly applied to commercial feed manufacturing. And I knew that I wanted to get a little bit more of exposure to the integrated side of things before I decided what I was going to do for kind of the rest of my career. So I had some conversations with Charles Stark, who at that time was at NC State, and said, hey, is there any way I could come down and do some things with you at NC State and get to spend some time around the integrated industry and see kind of what that's all about from the feed manufacturing side. And Charles had an availability to bring me down. He had some projects going on that he needed some extra bandwidth on. And so he brought me down, and round about that same time, there became a need to refill position at Kansas State through the interview process. Charles ended up moving back to K-State, and NC State asked if I would apply for his position. And I had decided at that point that I liked academia. I'd done a lot of teaching as an undergrad and had done some as already at my time here at NC State, and decided, I think I might like that. It's giving me some ability to work with students, but also still spend time in the industry. And it all worked out, quite well. And so I've been here, moved to North Carolina in 2012, but have been on faculty since November of 2013. So coming up on 9 years now.
Wow. Yes. K-State has an incredible feed manufacturing program. Really, really excellent.
It's become a very interesting thing, for Since, and I should know my history better but than I do, but basically the very beginnings of the feed manufacturing program at K-State go back to like 1950. And until the program was created in the mid 2000s, so like 2006, 7 is when they started the feed milling minor here at NC State. And between all that time, there was nobody else doing it, right? It was just a K-State thing, and they then brought Charles from Smithfield and asked him to start the program here. And since then, we've also seen, with other universities having to build new facilities, not necessarily because they want to start a program, but because they need new research facilities, and their feed mills are really old, and it's time to build new stuff. And they've decided the same thing, like there's a need here. And so we know that there are a number of other universities now that are also kind of jumping into this game of wanting to create an education pathway for folks that are going to go into the feed industry, which is great. The industry needs them, and I'm not going to get everybody that needs to be in the Midwest or the West or whatever to come to North Carolina, and we're not going to get kids from North Carolina to go to school in Kansas and all that. So we can use some diversity of education around so that we can fill the needs kind of nationally across the board. So
I absolutely agree. It's much needed, and we've been very lucky to have you there in North Carolina, kind of our go-to guy for the East Coast poultry industry. When I have feed milling questions, I know I always reach out to you. So very thankful to have you there. Thank you for not staying in Kansas. Although I know Manhattan is a hard town to leave. It's a very, very fun little town.
It's great. It's certainly it's still home kind of from that perspective, having grown up there and going back for college. But I love where I'm at, and it's actually pretty amazing. The allegories between Manhattan and Kansas State. Obviously, Raleigh's a little different because we're it's a bigger city, and it's the capital and all that. But as far as like the NC State thing goes, it's so similar to what I remember, being in school at K-State too, down to the rivalry between NC State and UNC, and it's the exact same as the one between Kansas State and KU. Like it's down to the last, they've got the law school and the med school, and we've got the vet school and all that kind of stuff. So no, I very much like where I'm at, and I still get a lot of chance. We still collaborate with the program back there at Kansas State. And still get to do a lot of things with those folks, and I've still got friends and family back there, and so it's nice to keep that connection. But we really love what we're doing here too. It's been fun, kind of continuing the building of this program, and we've got some really good folks on staff as part of our animal food program here, and good students and all that. So yeah, it's been a really good opportunity for me, and I've enjoyed it quite a bit, and looking forward to being here for quite a while.
So you mentioned a number of other universities are trying to expand into the feed manufacturing area and building some of their own pilot mills or refurbishing, renewing their old pilot mills. Could you talk a little bit about some of the unique challenges that are associated with running a university feed mill? Or in fact, building a university feed mill?
Well, that's two different questions, right? Building the building one is take, for anybody that's gotten involved in this in their time in the industry, even maybe kind of off to the side, take everything that you would have in the idea of building and planning a feed mill, all right? And we're obviously going to be talking about something on a smaller scale, but take everything that goes into that, all of the decision on what kind of equipment and process flows and layout and structure and all that's the same, and then build it inside the state agency, and all of the bid processes and all of the red tape and the figuring out the public-private partnership and the dollars and the donors and all that. And so it just escalates up on top on the complexity of the managing of the project. It's not quite as easy to say, hey, this is the company we always go to that builds all our mills. That's who we're using. Nope, you don't get to do that. You get to go bid it out and see who you find and stuff like that. So the building is complex, and I'm sure everybody else that gets to be involved in it would echo that. The running of them, to some extent, the same thing, right? Take all the normal complexities. We obviously don't have the complexities in most cases that quite come up with, people need feed right this second, or it's going to mess up the entire, food production chain, or I'm going to have animals that are going to starve. I mean, we're feeding research animals and they need the feed, but, absolute worst comes to worst, we're going to be probably in a situation where the research trial gets halted because something went bad at the feed mill and we got to go buy feed from somewhere else just to keep the animals fed, right? I mean, so there's a little less stress from that standpoint. The flip side of that is some of the feed we're making is just maintenance diets. And so we're sending feed over to the dairy and it's maintenance feed. And so it's just like being in a commercial feed mill. And so it's all the normal stuff that goes on with that. But the rest of them are all research diets. And so we've got faculty that would like to see their, every micro ingredient weighed out to the nearest hundredth, or if they had their choice thousandth of a pound of lysine, right? We're not going to do, this isn't going to be a 50-ton run or a 150-ton run or anything like that. And even in the case of the smaller commercial facilities, it's not going to be, oh yeah, every other week we make 6 tons of this for a customer. It's not that. So one of the things that's unique is in a given year, it's been a while since I counted, but in a given year, I think I counted 3 years ago, like probably right before the pandemic, 2018, 19, maybe. We had 650 unique formulas that we produced in a given year, because the vast majority of what we produce is a one-off. We make it this one time. Here's this broiler trial, swine trial, whatever it is. We're going to make starter, grower, finisher, and there's 8 treatments of each one of those. And then we're never going to make that diet ever again. And so the amount of formulations we go to, the amount of different ingredients I keep at the NC State feed mill, 70 different ingredients on hand at any one time. Which for an integrator would be a lot. For a commercial mill, there's some that are going to have more than I do. But my entire ingredient catalog is in the hundreds, because I don't stock palm oil, but it's not out of the question that I get an email today from a faculty member, a colleague of mine, that says, hey, we're going to do this trial and we're looking at some different things on different types of fat sources. We need to source palm oil for this. All right, now we got to go get it. We got to bring it in. We're going to figure out how to heat it so that we can then use it and all this other kind of stuff. So all those, it's the different number of it. The other thing, and I'll apologize ahead of my time to all my colleagues and probably to you as well. But one of the way I always tell the folks out in the feed side of the industry is, how many nutritionists do you deal with in your job? And like, oh yeah, we have the one in our company. And I say, so I've got like 12, and they're all, and to be fair, my colleagues are great. We work very well together, but they all formulate a little differently. They all have a different way of wanting to put their diets together. They all have a different perspective. We keep 4 different phosphorus sources on hand, because some people like monocalcium and some people like dicalcium and some people still want to use D-fluor. In a normal feed mill, it would be, we have monocalcium phosphate. This is what we use and we formulate around it. And we don't quite do that. So it's the day-to-day complexities of all the different types of diets and things like that come into it. And then the rest of it is, it's still a feed mill. And so stuff still breaks. And so I had a mixer shaft actually break on me. Just a weird thing. The mixer's not that old, and it certainly doesn't have that many hours and tons on it. It's just a bizarre thing. Nobody's fault. No, just probably something in the metal somewhere. Well, when I basically send an email that day to the university and say, I've started quoting it, and I don't know it all together, but I'm guessing this is no less than $50,000 that it's going to cost me to fix this, because it doesn't matter how big the mixer is at that point. Yeah, my shaft is on my 2-ton mixer is a little cheaper than what it might be on someone else's, but the labor of opening up the mixer and pulling it out and change, that's all the same. It doesn't cost me any less than it would cost somebody that's making 20,000 tons of feed a week and has a 10-ton mixer to do that job. It's the same job. And the university freaks out a little bit and they say, oh, you have that in your budget? And I'm going, no. Although we did find a way last year to absorb that into our budget. We had to not do some other things, but that kind of stuff comes up, right? Where, a motor fails, it's a $4,000 motor and we have to have it tomorrow if we're going to keep making feed. And that doesn't always work really well inside the university system. And so we have to do a lot of things there. ingredient prices are that way, right? All of a sudden, every load of soybean meal I bring in is $12,000 worth of soybean meal. Well, and normally around the university, there's a $5,000 bid cap. Okay, well, we can't bid every single individual load of soybean meal. So we had to come up with new ways to work around inside of our accounting system. And so we've got really good relationships going all the way up to university level purchasing that most folks don't have to deal with, because we can spend a lot of money very quickly, and we can sometimes have to spend it in an emergency situation. And so, those normal everyday feed milling things that come up, the university structure, to be fair, probably shouldn't be, but the university and the state structure isn't necessarily designed for some of that. And so there's a lot of learning on how to manage it, and building those relationships with all the folks across procurement and in audit offices and everything else, to make sure we're doing things that remain legal within the state system while trying to operate a facility. So the research and the management of it can get complicated from that standpoint. But the stress level isn't quite what it is of, oh my goodness, this went out. We've got, 8 million birds right now that need feed, and we can't make feed today. Like, at least I don't have to deal with that. And so that's certainly the flip side of it, which is nice.
Yeah. Different stress.
Still
very stressful.
Yeah, sometimes. I got good staff. I have an excellent staff that runs our feed mill. So most of the time I just kind of get the fun job of overseeing it, and they're the ones that are answering the phone calls and trying to figure out, what do you mean your birds are out of feed? You said you only needed 3 tons of this research diet and that sort of stuff. And they handle all that. They handle all that quite well. They do a great job. So I'm lucky there.
So what kind of opportunities exist for, the industry to support what is a very important program? I mean, to have people coming out of school with hands-on experience in day-to-day feed mill operations is priceless, to not have to start from scratch when you're training somebody. What is the route that that the industry could go to help support the university feed mill and the department as a whole?
Yeah, it sounds like a great question. It sounds like I teed you up for that. I swear
he didn't. Just for a note, he didn't. I just really believe in the value of extension programs.
Yeah, no, and I appreciate you asking. So that's something that we're currently working on now, actually. A lot of it honestly has to do with all the other universities that are kind of coming into this space, and us wanting to say, hey, this facility was built and went into operation in 2008, and the program started, but we're still here. We're still a big player in this, and you may see a lot of this other stuff, in the magazines as these other programs and these other facilities come online, which is awesome. But we've said, okay, 10 years is a long time, especially when we talk about wanting to train students and having the newest technology and all that other kind of stuff. Things move really fast. We need to start doing some raising of capital so that we can make those changes and make those improvements and add things. And we do what we can with kind of the budget that we have, or the way the mill works and the program works is the feed that we make or the outside research we help with generates some income that we can put in. But it's not enough that I can go replace an entire pelleting line with something more modern, right? That's a larger chunk than we're going to be able to generate in a year and then spend out in the year, sort of a thing. And so that's one of the things we're doing now, actually, is we're beginning the process of trying to go out and talk to the industry and the folks that would support us and say, okay, first of all, how is our relationship right now with the industry? Are we providing what's needed? Are we having those relationships that in the way that they need to be? Let's make sure that we're all happy with that first. What do our programs need to look like? Are the students that we're sending out meeting the needs, or do we need to rethink some of those things? Which actually I think we do. And so we've got some opportunities there. And then basically it becomes who would like to support us. And there's everything from, the basic university situation of writing gift checks that come to the program, and those can sit in an account until we get enough money to do things, all the way up to the potential of, you'd actually like to, name something like that, right? One of the big plans that we have that we hope to do is, when the feed mill was built, it wasn't built specifically with any like classroom space with it. And when we take that idea along with, we do something every fall in November called the Feed Production School, the CFIA Feed Production School, and which is Carolina Feed Industry Association. And it's been a fantastic program. It's the folks at CFIA, and then we hosted it at NC State, and then Chandler Adams, who is a rep for a number of different companies. Most folks know him as a CPM guy, but he reps a lot of different stuff. He does an amazing job of pulling speakers in and all that kind of stuff. And we bring 80-something people to this, and we don't have a great space out there to put them. And so we cram them all into one of the smaller kind of conference areas we have out at the farms, but we like to have it out next to the feed mill because people want to go next door and see the mill, right? And so we've got this idea of, we'd like to maybe build some space out there that would be able to host larger gatherings, that would have classroom for when the students come and we're doing labs, that would have some maybe lab space and all that kind of stuff. So we've actually drawn up some plans for that and have some ideas. And our hope is to maybe do some fundraising for that. At the same time, say, okay, for every dollar that we bring in, X goes to the fundraising of that, and Y goes over into this enhancement for the feed mill itself. And so that we can, repair and bring back to the way it was in 2008 when it was new, some stuff, just wear and tear on the facility, and then add things to it. Automation things through Repeat, who is our automation supplier, sensors, and like I mentioned, some new equipment lines to be more modern. And so it's trying to make sure that we've got the right relationships with everybody that's out there, and then asking them what they're willing to support. And we know that it's a situation where, it could be a lot of small gifts that get us to our goal, or it could very well be somebody that says, hey, we want to be a big supporter of this. We want to put our name on it. We'll write one really, really big check because, we're in big support, and probably something in the middle. So, anybody that's interested in talking about kind of what we're doing, we kind of have a team together of folks that are advising on it from the industry side, as well as, ourselves in the program and our advancement office, to figure out what the best way to do it is going to be. But we definitely don't want to be in a situation where, 10 years from now, we're looking back and saying, well, the facility is 20 years old, and we're still teaching students in it, but it's not the most current stuff that we're teaching them on. And, kind of look back and say, well, we're going to be at a point where we're going to have to build something new now, versus we could spend the money and just kind of keep it up to date as we go. So that's our goal. And we hope maybe over the next, 2 to 5 years to really do quite a bit of those things. That's kind of the time frame we're looking at.
That is fantastic information. And certainly for any of our audience members who are decision makers in the industry, please support your university wherever you may be.
Yep.
Those programs are training your future employees. They are also providing training to your current employees.
Absolutely.
And they are a tremendous resource. As I mentioned, I've reached out many times about, field questions, troubleshooting questions that I just couldn't get a handle on by myself. So thank you so much for that information.
Sure. You bet. Thanks for asking.
Moving to talk a little bit about your research work, I noticed some of your work is centered on feed mill applications for NIR. Could you talk a little bit about that? What is the state of NIR in the feed mill? And really, I'd like to ask, we hear a lot about inline NIR. Do you ever think we're going to get there in the poultry industry? I really hope we would. But what are some of the challenges you see with that? And then what are some of the benefits of utilizing NIR in the feed mill?
Sure. So the first challenge, I think, with NIR, and the one I see when I go out into the industry, is one that's existed, frankly, since benchtop NIR showed up. And it's too much of the idea that someone bought this and it's a magic box and I'll never send another sample off to the lab again and all that kind of stuff. And and that's not how the technology works, right? It's no, you're still going to send samples off to the lab. You're going to bias what you have against the lab that you prefer. But what it does give you is, instead of, okay, we've got our schedule of sending samples off, and we're sending, one sample of this feed type once a month to get analyzed, or this ingredient or whatever. Now you still do that, but you also have this machine in there to every sample in between you can do on site. And so the amount of information you can grab is astronomically higher, but you got to manage the machine first. And I mean, I go to places where someone bought this thing and they invested the money and they trained on it, and now it just sits on the desk and doesn't get used because they thought they were getting rid, or somebody when they did the budget said, oh, we're not going to have to do lab samples anymore. And then when that wasn't exactly the case, people stopped being so interested in, wait a minute, was this financially a good idea? Because they approached it wrong, not because it's not a good idea, but because they approached it wrong from the jump. The amount of data that you can grab, I mean, even if it's just basic proximate data, much less what you can do with some of the cloud-based applications with the different companies, where you can upload your spectra and they can do more with it and give you digestibility and all other kinds of stuff. That someone finds something new to do with NIR all the time becomes huge, especially as we start. And I'm going to use this term, although sometimes I hate this term at the university, the big data.
Mm-hmm.
My joke around here is that if I walk around the halls and I say the words big data and microbiome like loud enough, someone will just drop money out of the ceiling because those words are so important. But the feed mill is a great place for this idea of big data. We always talk about the art of feed manufacturing. And what I usually tell people is a lot of the reason that it's still an art is because we don't have the ability to collect the data to make it a science. I can sit in the feed mill and I can hear something going with the pellet mill and go, hey, it's about to plug. And people like, see, that's the art of pelleting. And I'm thinking that's true. But if I had some sort of a sensor that was picking up the same thing that I'm picking up in my ear, it would know it too, right? And so there's a science there. It's just our brain is the best supercomputer that there is. But the NIR plays a big role in that. And so if you could grab every sample and you could constantly be looking at all this different information and throwing it into something that was regressing the data and figuring out nutritional trends and all that, there's a huge amount of power there, right? So that's just on the benchtop, but it takes a lot of work. So that then goes to the inline. So you referenced some of the research that we've done. We've got some stuff right now that is that's been shared. Andrea Rubio is one of my PhD students, and she's done some work on it relating to the mixer. And she shared some of her data at some of the meetings and things so far. And we've got an article that's in review right now to put some of that out into the actual press. What we were looking at is the ability of using inline NIR to basically measure mix uniformity as feed comes out of the mixer, both just from the standpoint of, hey, then every single batch of feed as it was going through the conveyor, leaving the mixer, you would know, are we meeting our nutrient spec? That's a relatively easy thing. And we've shown, I mean, yes, it can do that. It can do that just fine. It can do that quite well. The uniformity thing is a little more tricky, and we're still working with the folks at Bruker on what that would look like. They're the ones that we use their inline NIR, and they've been a big help on that. As we all know, using something like protein, for example, for doing a mixer analysis doesn't really work because it's not single source. We got protein coming from so many different ingredients. So we can't just use the basic proximates, but what we're trying to do is basically look at the noise that the NIR is seeing and seeing if we can tie that back to what we know was the uniformity based on doing normal kinds of mixer analysis on the same batches of feed, and seeing if we can't basically train the system to look at what the coefficient of variation is in that batch of feed. Our thought process being that we know, and we've got some data on this as well, part of the same experiment, although we couldn't get actually as a bad mixer CV. For anybody that's out there that's got like a twin shaft counterpoise high speed type mixer, so what our research shows is that we can't mix a bad batch of feed, just so you know, as long as we don't overload the mixer. But we could get CVs differences, from 4 to 5 up to like 12 to 15. So still not crazy. But when we feed that to birds, we can't pick up the differences. And we know that from some of our data and from previous data that's been in the literature for years. As the animals get older and bigger, so larger birds or older pigs, whatever, CV becomes a little less important because the meal size gets bigger, right? So is there the potential to use something like NIR to say, hey, I can know the mixer CV coming out of my mixer every single batch of feed, and therefore if I'm time limited. If I'm not time limited, then just mix the feed as well as you can. But if I'm time limited, maybe in an older facility, and I'm making 150% of what the facility was designed for way back when, and I don't have enough time to batch my feed, well, maybe can I borrow a minute of mix time on my finishers and devote that over here to my starters, so I'm getting really good mixes on my smaller meal size animals. And it's not quite as good on the larger ones, but the data shows the animals can't pick up the difference.
Mm-hmm.
Well, it seems like a good idea, but I'd want to know what the CV was. So can we use inline NIR for that? You asked about where's it going. I mean, the holy grail, right? The holy grail. And we know that people are using it to do inline measurement on particle size.
Mm-hmm.
And we know that works because if I'm doing bench top and I grind the corn one way and I grind the corn another way, I get two different answers on my nutrient profile.
Mm-hmm.
So some work that JT Pope did when he was my previous PhD student. JT's now with Nash Johnson House of Rayford. We ground stuff to a whole bunch of different particle sizes. We did that work with FOSS, and we were able to verify that, yeah, there's a difference between the different particle sizes on the exact same lot of corn, like the exact same corn, and we could pick it up. Okay, so NIR, if it's trained, can actually do particle size analysis. Cool. And we know there are folks doing that. The holy grail, though, is sticking inline NIR in each one of our ingredient conveyors coming into the scale, and knowing, and in effect, instead of putting into my automation system the actual formula, it's 67% corn, 27% soybean meal, et cetera, I'm basically putting instead what we put into least cost formulation program. I want this much protein, this much fat, fiber, all this other stuff. Here are my bounds. Here are the prices, and letting it do it. And then now letting the system say, hey, we seem to be on a slightly higher trend protein of soybean meal here. We can back the soybean meal off a little bit. It's pretty expensive. And put in a little corn, adjust the lysine, and I've got a diet that's now 30 cents cheaper per ton on the fly, right? Here's what I think, and I could be wrong, but I'm pretty sure I'm not. I think from the standpoint of the NIR technology, the ability already exists to take a single NIR, run it through multiple different channels, and as long as you're not pulling all the ingredients at the same time, put a camera in each one of those and pull that information. Okay, that exists. I can't imagine that somebody out there can't then program everything that we just said and create all the crazy artificial intelligence stuff we see. The fact that couldn't be done, and in fact, I'm fairly certain there's a few feed mills, I think in South America, that are already doing some of this, right? So is it possible that we could do that? Yeah, it's absolutely possible. Is it currently economically feasible? No. I know that I believe again, this goes back to why we want to do things in our mill. The new feed mill in Illinois, Bueller did a lot of the automation and things there. I believe they've installed inline NIR in their feed all throughout it, so that they can play with some of these kinds of things. So it's absolutely the future. Is it cost effective for everybody to go put in right now? No, we're probably not there yet. Mm-hmm. But does it seem possible from, in the long term that we get to that? Yeah, I absolutely think that it is. So there's some really, really cool stuff on there. The other fun part about that, and it goes back to the education side too, right, is it's kind of like when all of a sudden all the commercial mills started putting automated bagging systems in. And now, okay, I no longer need 3 employees, 1 sacking, 1 sewing, and 1 stacking. I only need 1. That's great. But this one actually has to understand some things about like robotics. Mm-hmm. And I never needed that employee before, right? I needed manual labor. I didn't need this. This is the same thing, right? It's, well, we can do that, but is the maintenance people that I've always needed to hire, that I needed mechanics. I needed people that could turn wrenches and all that. Well, I'm still going to need that. And now I'm also going to need a computer science person on staff, that it is at least as part of my complex, from the integrated standpoint, that can go around and, be on the phone. They may not be fixing it, but I need someone like that can be on the phone with the people when they're saying, okay, go into the interface and I want you to change this and we're going to try to recode it. And those of us in the mill are going to go, oh, no, you're going to have to send somebody for that. So I'm going to have somebody that can do those kinds of things. So that'll be another part of it is meeting the technology with people that can do it too,
That's a really good point. I hadn't even thought about that. That holy grail situation, I mean, that is probably the feed cost savings alone, not to mention meeting the nutrient requirements of the bird more specifically, is I would guess, multi-billion-dollar question.
I think so. Yeah.
I mean, it's astronomical to think about. Do you think it's close enough that someone building a feed mill in the next decade should be thinking about building that mill so that it could accommodate inline NIR?
Yeah, for sure. Definitely, I would definitely say the accommodate part, right? Definitely from the standpoint of I'd be having conversations with folks of, all right, maybe we can't afford to do it now. Maybe nobody even knows how to tie in, bringing the NIR into the repeat or beta or WEMS. Maybe we don't know how to do all that yet. But I definitely want to accommodate it is what do I need to know about how I'm installing screw conveyors, making decisions on where stuff is located. Something as simple as, do I need to have a dedicated room over here that could house the cabinet and everything that I would need so that it's not, I don't want this is $100,000 piece of equipment with a whole bunch of fiber optic line going around. I'm not just going to sit it there on the floor to get run into by the forklift, right? Do I need to make sure I've got, something as simple as that? I'd be having those conversations for sure. Then, of course, if we're building a mill in the next 10 years, it's probably going to be operating for the next 30 to 40, the way that, mills are, 30-year life or longer. We've got mills out there that are, 100 years old too, right?
Oh, yeah. I felt a little personally targeted by your comment about older mills running at 150% capacity, but I think that's the state of the industry right now.
Yes, it is. And so, yeah, I think you're 100% right on. If those are the kind of things, I'd be having some real conversations about what is that technology going to look like in the next 5 years, 10 years, 20 years. Let's make sure we're building it to accommodate it now. Because even if we're not ready to install it, we see it when people are building mills now, right? Where they do it on capacity now. It used to be you built it to the capacity you needed and maybe you plan for adding on over here. Now we build the mill and we have a whole bay for a third pellet mill over here because it's cheaper to build it now and install it later if we need it. Same thing would be true here. Hey, put the conduit in and whatever else to be able to run this stuff because it's going to be a heck of a lot easier to do it now than it will be to do later. And if you never use it, by and large, it probably didn't cost you all that much, but chances are you'll find a way to use it for something else. So, no, I think that's right on. I think that would make sense from a planning standpoint.
I think in the near term, the mixer profile and particle size applications sound really, really promising, particularly from a labor standpoint. I mean, I think you're doing fairly well if you're measuring those things a few times a week. Particle size a little bit more, but mixer profiles, I mean, they take time to come back, and keeping it within some set specs, you feel fairly confident in it. It's those times that something is actually wrong with the mixer where that would allow you to see it right away as opposed to waiting for sample results to come back.
Exactly. How nice would it be instead of getting there, oh my goodness, if it was just like anything else tied into an alarm in the automation system. And it said, this batch recipe says that you want a CV of 10% or less or 15% or less, whatever you want to set it at based on your rules and regulations and whatever else. And the thing comes up with an alarm and says, hey, you're trending out on this. Someone might want to go open the mixer and see if there's buildup or a broken ribbon or whatever, right? Yeah, that'd be really cool to do. And yeah, I think that stuff's coming. I think it's going to take some time, just like anything else, and take some money, but I think we will get there. And then goes back to what we were talking about data. Now I've got nutrient specs on every individual diet, and I can say more or less, which farms most of that feed went to, and I can tie that back to the processing data at the processing plant, what birds came from what. And now I've got this huge from the start to the end of this was exactly the nutrient profile, but it was slightly made up differently with a little more synthetic amino acid and how it's specifically to that tie to breast meat yield. And I've got the data now, and I've got this giant database, and now we can go look at stuff that we could couldn't only dream about before. And now we're still dreaming, but we can kind of see the possibility. Ask somebody, 10, 15, 20 years ago, and we would have said, I mean, I don't know, someday in the future, some sort of science fiction may allow for that, but I can't even imagine what it would be. Now we can say, oh, we've got the tools. Now we just got to figure out how to put them together and pay for it. So,
and handle the big data.
And handle the big data. Yeah. The people that want to go and bring that. We've actually had some graduate students here that have, been in poultry science or in animal science, and they've basically slapped a big data project onto there and started taking some of these classes over in engineering and computer science and things like that to learn about it, because they've realized, hey, that's going to be a part of my world. And we've had a few even PhD projects that have, focused on machine learning and things, trying to figure out how to, agricultural data can feed into that from a live production agricultural standpoint. Yeah. Could
you see maybe an undergraduate emphasis on that computer science merged with poultry science in the future?
Absolutely. Again, and this is where I'm going to get in trouble when someone from my university watches this. I plug other universities, but again, I think that's something, because of what they're doing with their mill at Illinois. Some of the stuff, if you read about theirs, they've got a concentration where they're gonna take kind of the nutrition animal science side and the computer science side and build it together. And yeah, here at NC State, we've got some programs that are similar. Folks can, for example, take do a degree in what's called ag science, where it's more of a generalized degree, but they can pick 2 different areas to go. And so they can say, hey, I'm going to merge kind of a minor in poultry science and a minor in bio and ag engineering, and I'm going to stick those together to create a degree. Or I'm going to take something like computer science and animal science and stick those together because, I'm interested in, I've always been around animal ag. I grew up with it, but boy, do I love computer stuff. We tell people that all the time, students that come in as freshmen and tour the mill and stuff. And I sit there and I look at them, I say, look, see all this automation stuff? This is the future. And in fact, right now, this is state of the industry. So if you're someone who sits here and loves that, you don't have to be the person that goes out into the chicken house and is doing something. You could sit behind a computer and have a huge impact on our industry too, right? So if you're not the hands-on person, there's that. The cool thing about our industry is if you are the hands-on person, we're still going to need you too. If you're like, look, this automation stuff is for the birds, for me, cool. We still need someone to go out and actually look at the birds and pick them up and do all that work too. And so there's kind of a home for everybody, which is really nice. And a lot of industries, it's not like that anymore, right? It's like, I'm sorry if you're the one guy who wants to build the car by hand, you can go start, something where you're doing something boutique, but you're not going to come work for General Motors anymore. We need you to be able to do it all on the computer. So.
Well, I love to hear that there's more flexibility in the degree programs to accommodate all those different interests, especially because it sounds like I'm going to have to go back to school, so I'm not an obsolete old lady in 10 years not knowing any of this computer science stuff. So I'll look forward to that.
We've talked about it here. So we've got in our program, poultry science, for example. So I've got my feed milling minor, right? But just as the degree overall, there's the science concentration, there's the technology concentration. And science is largely those that are going to go on to graduate school, vet school, things like that. Technology is more the industry focus. And we've had some really good discussions amongst our teaching faculty here just in the last 6 months of, we're calling it technology. Let's really start focusing on the technology. Let's figure out how to bring that into our classes. What do we need to add? What are we not talking about? So that the students can walk out of here and hit the ground running with these new technology ideas, whether it be data handling or knowing how to run automated housing systems or the systems that are running the processing plant or the feed mill or whatever, and really wanted to focus on that. So that's a focus for us here at NC State, is to go all the way from the actual day-to-day working technology all the way up to the data analysis, and then bring that all together with the understanding of the physiology and nutrition and management of the animals as well. I think there's huge opportunity for growth there, and most of our teaching faculty are on that same page. So we've got some exciting work ahead of us on that side too.
Very exciting. Very exciting. Well, changing lanes a little bit, I wanted to talk to you about still associated, but pellet quality. And specifically, I find that when we talk about pellet quality issues, especially troubleshooting, we spend a lot of time on, particle size and the microstructure of the pellet. temperatures, times, but what gets neglected a little bit is the moisture component in the steam. And I wonder if you could talk a little bit about, I don't want to say the art of steam quality, but apparently we don't have enough data. So the art of steam quality,
Yeah, right.
and why it's important to have not only feed mill staff who are, experts in that area, but also to bring them into these discussions when you're talking about pellet quality.
Yeah, that's a great question. So we've done some work actually just recently here. We've been playing around pelleting. I mean, going back to when I was an undergrad and running stuff in the mill at K-State all the way up through my PhD project. I love spending time around the pellet mill. That's kind of my favorite part. And so a lot of my graduate students have kind of picked up on that, and they've chosen their projects to go in some of those directions. We've done some really cool stuff on looking at the impact of the different areas inside pelleting, steam conditioning, and the pellet die itself. JT did a bunch of that work on the survivability and the nutrient specifications of feed as it's coming out based on heat and time and moisture and all that other kind of stuff. Some others around the country and around the world have obviously done that work too, and we're building up a pretty nice catalog of information. So a master's student of mine who she's just graduated. She's now down at the University of Florida doing some stuff on like 3D printing of fish proteins and things like that. Some really cool stuff that she got interested in doing some of the work she did here. She was originally a poultry, kind of a poultry person. Her name's Sharon Chua, and she did her master's work. And that's what we looked at, right? We looked at a bunch of stuff with moisture. And we looked at what if it's coming in from the mixer? What if it's coming in from the steam? What if it's a little bit of both? How does that? And some of it is stuff we already know. I mean, we know that if we use moisture coming from steam, it's more effective. If I add 4% moisture via steam versus 4% from the mixer, the steam's going to do a better job. Like, that's not groundbreaking. But we did find some pretty cool stuff about, well, what if we couldn't get to 4 and we could only do 3 in 1? What does that look like? And so we did some really neat things like that. Those articles are actually also currently in review. So hopefully those will be out soon. We also ended up doing some of the work on what's happening. You said microstructure of the pellet. What's happening there? And we did a little bit on like the starch gelatinization. That's always kind of an interesting one because a lot of folks still want to talk about starch gelatinization, although in reality in pelleting animal feed, we gelatinize some starch, but it's not like extrusion, right? We're not doing huge amounts of it. And it doesn't really tie back to pellet quality. Most of the time when we look at the amount of gelatinization we see, which is pretty miniature. In fact, sometimes we gelatinize more going through the hammer mill due to the friction we create there. We certainly do more gelatinization moving through the pellet die than we do going through the steam conditioner. But what we found while she was looking at that, and she did some cool scanning electron microscope looks and some other stuff, was some really neat things related to like glass transition temperature of proteins and the amorphous actions that happen of the proteins inside the pellets. And that gets tied a lot back to the moisture. So adding enough moisture to have enough heat transfer that you are changing that transition temperature that the proteins can start to move and do some of the gluing. And the starch plays a role. It's just not huge. And it's probably not worth targeting a certain percentage of starch gelatinization in a lot of cases, at least especially with with chickens. Some of the monogastric species, the pigs, and the cooked starch may help them a little bit, and chicken less so, right? Turkey less so. Not to say it can't help at all, but the protein thing was really, really cool. And so when we go back and we look at that, it does, as you said, have a huge amount to do with the amount of moisture and how we're getting it in there. From a steam quality perspective, there's two parts to look at that. There's the looking at it from the nutritional and the pelleting and the pellet quality aspect. And then there's just flat the engineering aspect of moving it through the feed mill. The overall idea, and there have been theories for years, people of, well, you should take the insulation off of the steam piping so many feet before this so that you start to get some condensation, which seems like a really bad idea because we spend a heck of a lot of money over here to take natural gas and turn water into steam. And that is not a cheap process, especially these days. And if I want to add a little bit of water, I can run a water line and spray some water into the conditioner, right? It doesn't make sense to intentionally lower my steam quality, and I could just add water there instead. Like that's a way cheaper alternative. I can do it in the mixer too, obviously, but I can set it up to be sprayed in at the conditioner if I wanted to. The other thing that we hear all the time, and I see it when I go into feed mills, is this idea of changing the pressure before it goes into the conditioner for wet steam versus dry steam. We also hear things about, well, we do a different total dissolved solids in the winter and the summer and all this kind of stuff. And I'm not going to say that changes don't occur, because they do. But there is no one size fits all, because everybody's boiler is different. Everybody's steam piping is different. The age of the facility is different. The type of valves you use is different. Some people have really good steam traps because they're keeping up with them and fixing them when they need to be. Other people have steam traps that haven't worked in quite a while, and they're sending huge amounts of steam back to the condensate return, all this other kind of stuff. So any idea that, oh, this one way of doing it is going to work for everybody, that doesn't work in feed milling in general. I mean, I don't care what part of the process we talk about, from receiving to loadout. Because it works for you doesn't mean it works for your neighbor, right? But one thing that we talk a lot about is that pressure. And okay, well, when we go to higher pressure, there's more BTUs per pound of steam, therefore it's drier steam. Although if you look at the range that we typically operate in, which is somewhere between like 20 and 60 or 70 PSI, and you do the math on a saturated steam table, the amount of moisture difference there is, you couldn't take samples out of the conditioner and analyze it and find it if you wanted to. It's so minuscule. However, what probably is happening, this is always a little difficult to explain because it seems counterintuitive, but when we go to a higher pressure steam, that steam occupies less volume. And so that my water vapor is all very condensed in one spot, right? And what I'm actually doing when I'm conditioning and I'm pelleting is I'm adding a certain amount of water, to get my up to 16, 17% moisture before I pellet. Well, that steam, okay, because it's high, it's more compressed, moves more slowly actually through the system. It's still moving pretty fast, but it's moving more slowly than the low pressure steam. And so because it's so compressed, it can move more slowly and deliver the same amount, pounds of water. Because it moves more slowly, water is much more likely to fall out into the drip legs where it's supposed to go, get pulled out in the separators, get pulled out in the steam traps, all that kind of stuff. And therefore it's not carrying any water with it. The steam quality is, quote, higher because it's moving slower and the system is being able to do what it needs to do. We go to a really low pressure steam, that stuff has to fly through in order to get where it needs to go. All the water, any lower quality, let's say it's 98% steam quality and I got 2% basically water being carried, it's not coming out of the stream. Nothing can pull it out quick enough. That stuff's flying through so quickly. And so therefore we get wetter steam, but it's not a thermodynamic thing, it's a physics thing. The other thing that is a really big part of that is, as we're controlling the amount of steam that's going into the conditioner, we're doing that using some sort of a valve. Most of the time we talk about Mason-Nealon valves, but there's other kinds as well. And basically it's a percent open, tells me how much steam I'm passing through. Well, if I'm at a lower PSI and the steam occupies more volume, I'm going to need more of a range of opening of that valve in order to modulate my steam. And that's a good thing, because I can tell the automation system I want to bring the temperature down, and it can close it from 65% down to 62% and make a little bit of a change. But if my pressure is really high and it's all really condensed and dense, in that same situation, now my valve is only operating from 0% open to 15% open. And when I tell it to make a change and it drops at 1%, that's a huge change. And so modulating the steam becomes a lot different. So it's certainly has this impact on pelleting and pellet quality. And like I said, we've done some cool stuff here about what it impacts the nutrition, and all that's incredibly true. We've learned that the actual action of things is more in the pellet die than in the conditioner, but certainly how much moisture we add has a huge impact on what happens in the pellet die. But just the controlling of the steam usually comes down to maintenance and physics. It comes down to making sure you have all the components that actually work the way they're supposed to. And like, steam traps and valves aren't cheap, but if you go look at the amount of money it costs to turn all that water into steam, and then it's not being adequately applied because you're not spending $1,000 or something on this trap, that's not money well spent. Um, and so there's a lot of it that just comes down to the management, the maintenance, and the kind of understanding of the physics of it as much as anything. And then obviously we have go into facilities and you say, well, what's your retention time? And they say, it's 45 seconds. And I say, well, how do you know it's 45 seconds? Oh, because when they installed it, they told me it was 45 seconds. And I'm saying, okay, well, what did you want? And they said, well, we wanted something that would do between 30 seconds and a minute. I'm saying, well, if I were installing it and I was selling it to you, I would also tell you it's 45 seconds. Like, have you ever verified what your retention time actually is? Have you ever popped the thing open, scrammed it under load, popped it open, and seen what your conditioner fill looks like? Do you actually know what's happening inside that conditioner, that you're getting good fill, good retention time? Have you adjusted picks and gotten everything just the way you know? And we got some folks out there that rep equipment that won't let their facilities not do that stuff, right? That are just excellent at that, providing that technical service and saying, no, we're going to dial you in from the jump. We have other situations where, stuff shows up on a pallet and the millwrights install it and they turn it on and we go, and nobody goes through that work of validating their system. And so to make sure that steam conditioning is doing what it's supposed to, all that needs to be done, and it needs to be watched. We also see just simple things, all the piping coming into the conditioner. It's called the steam harness, right? There are places out there where the steam harness is like spaghetti. And honestly, the one at the NC State feed mill is a little like this. It's on my list of things to change. And there's just pipes going everywhere and you can't quite figure out what they're doing. And then there's some that are in new installations that are incredibly elegant and they're very simple, and they're very balanced. So when one pellet mill chokes and shuts down, it doesn't affect the other two, all that kind of stuff. And again, that's physics and engineering more than it is anything else. And so it's having the right people involved that can help make those decisions and do those designs makes a huge difference.
Mm-hmm.
So
absolutely. That's wonderful summary on steam. A lot of information. That relationship between steam velocity and moisture retention and the condensate loss has always been very counterintuitive to me, that you would think the high pressure, you would think it was the opposite. So that has always blown my mind. Very important principle. Additionally, what you talked about with making sure you have enough finesse on the adjustment for the Mason-Dillon valve, very important. And I do agree with you that we often see on the maintenance side people stepping over dollars to pick up pennies, and that really shoots you in the foot, especially with energy costs being as high as they are.
Yep, I would say, I might have a whole bunch of feed mill managers that would yell and scream and disagree with me. I feel anyway, based on conversations I have, that we are at least moving more towards the idea of the feed mill being looked at as a part of the whole where investments can be made instead of just a cost center. Mm-hmm. Like for a very long time, please make the feed as cheap as possible, as fast as possible, right? And I think we're getting a little bit more towards that ingredient cost, fuel cost, driving that a lot. But the more we learn about feed quality and the importance that it has and all that, makes a big difference. And also the more enzymes and probiotics and high expense feed ingredients we're using that are also need to be handled with some care, whether it be how they're weighed out because they cost $5 a pound, let's please not waste it, all the way to making sure that we're adequately mixing them and pelleting them. It feels a little bit like we're transitioning into the idea of, no, we need to pay attention. We need to spend some money over here to make money. And so hopefully some of that, but it still holds true that it's like, well, I'd like to overhaul this, and it's, well, show me the return on investment. And if it's anything over 2 years, you're going to have a hard time selling it, and kind of getting out of that mindset on larger things that can really make big differences is still a work in progress too. So
yeah, it takes the data collection and analysis power to be able to prove that return on investment. And exactly. For a lot of things, that's just not there yet.
Exactly right.
Before we wrap up with our closing questions, I just wanted to touch briefly on training courses for preventive control qualified individuals. I was fortunate to take that course at NC State a few years ago. We've been seeing more of these courses kind of pop up, which is good because it's necessary to train individuals in the feed mill. I just wanted to check in with you about if people cannot attend the excellent course at North Carolina State due to geography, timing, etc., what should they be looking for in those training programs to make sure they're attending a quality training program that's focused on feed mill FSMA? And then which personnel in the feed mill do you recommend get that training?
Yeah, that's a great question. So we still do ours here. We've kind of shifted ours here to somewhat on demand, meaning so my colleague Marissa Cohen, she's our area specialized agent for animal food safety. She runs the courses, and then I help her instruct them. She just collects people asking when's the next course going to be. When she's got a big enough group, we hold one. Here in North Carolina, our numbers have dropped off a little bit because we're so heavily integrated that we've kind of trained everybody. It feels like in a lot of ways, although most of what we see now are the smaller commercial kind of things, or people that are just getting into the animal food world a little bit. So we'd love to see more folks. And so a plug for ours, if you're interested, find me, find Marissa, let us know you want a course. We'd love to train as many people as are interested in being trained. Beyond that, so I'm always going to be a little biased towards the group that was involved in the original creation of the curriculum. So there's an excellent one that's done at Kansas State, and it includes Cassie Jones and Dave Fairfield from NGFA. And Cassie was another one of the authors of the curriculum, along with me and Charles and someone named Brandy Miller, who was the adult education specialist. We kind of wrote the curriculum, but when we did it, we had a group. It was about 10 or 15 advisory folks that were in the room at the same time. And that's what we call the TOT group now, the trainer of trainers. And if you can find a course that's also being taught by a TOT that's been around since the beginning and knows all the stories of how stuff came to be and why it is the way that it is, those are awesome. So if you can't make it to ours, which come to ours, that would be great. We'd love to have the numbers. But the ones that Cassie and Dave do at K-State are great. There's a few that get held at various different universities as well. Those are usually pretty good from the standpoint of those folks have a specific kind of knowledge base, obviously, that they're working from. Like you said, that they're not just trainers; they're folks that are actually involved in the animal food industry. And I think, and when you go look for courses and you go to the FSPCA website and you look for them, it can be a little hard to figure out the expertise without doing some additional legwork. But if you see one and you think this might be good, it's held at this location, here's the lead instructor, do a little bit of legwork on that lead instructor and see what you find out. I'm not going to say that anybody that's just, a trainer, like this is their business, they're a consultant that does training, doesn't do a good job, because there are some out there that are excellent. But if you can find one where you find this person's bio and whether they work for a company or a trade association, AFIA, Gary Huddleston at AFIA, he runs courses for them. And if you were to go look up his bio, or Dave Fairfield at NGFA, you go look up their bio and you find out, they ran feed mills for 20 years and then they switched over to doing the regulatory side of stuff. Or if you go read my bio, and which we've already covered, or if you go read Cassie's, and Cassie's turned her whole program, her whole research program, in addition to her teaching, but her whole research program is about animal food safety. Like that's what she does. Yeah, these are good people to go take it from. So do some legwork on those, is what I would say, and look at it and say, okay, is the lead instructor that's listed, if I go figure out who they are, does it look like, oh no, this person very clearly has some expertise in animal food manufacturing or nutrition beyond, just being trained to take this course. So that would be my advice as far as that goes, beyond just come take the one at NC State and let us know you want it. As far as who should, Certainly anybody that's in charge of or related to quality, because quality is, the quality assurance group is usually also going to be kind of the regulatory affairs folks as well. Beyond that, there are some companies that seem to have decided they're going to have everybody. They're just going to make everybody in the whole place trained, almost down to the basic operator level. But certainly the plant manager, the production supervisors, the assistant plant manager, and all the QA staff, they're all going to be it. By the rule, you have to have a PCQI to write the plan. Most places already have the plans written. So now it's more about understanding how the plan was written, why it was written, and being able to act upon it and describe it in the case of an inspection or an audit. And so the way that I would look at that if it were my facility is, actually, I say that, the way we have looked at it in our facility is anybody that might be in the chain of command that could be the one that ends up sitting there having to explain the plan, I have trained. So if the inspector shows up and wants to talk about the plan, then I'm going to try to be there. But what if I'm traveling? Okay, well then Marissa's there, and actually Marissa would be there anyway if she could be there. But what if we're both at the same conference and traveling? Okay, well the feed mill manager is, and both of my graduate students are, right? Like they're all trained because they could be in that chain of command of needing to speak to the plan, and obviously they're in the chain of making sure that the animal food is safely produced every day, and that's what it's all about to begin with. So anybody that has that ability to impact the safety of the animal food directly, and maybe not all the way down to the operator level, but certainly that supervisor level, one step up, and anybody that is going to be responsible for talking to the inspector when they're there looking at the plan, that's the groups I would say it's probably worth going through the process of getting them, finding the 20 hours to send them somewhere and get them trained. That's my opinion on it.
Strongly agree with that. In past experience, you feel a lot more comfortable during those inspections and audits when you have someone there who there will always be someone there because everyone is trained who can speak to the plan. Exactly. And it also, I think, gives people, even down to the operator level, if you have long-term operators, I think it gives them an extra sense of the stakes involved and why they're being asked to do the things they're being asked to do, and gives them some more agency in their own position. So very valuable program. Well, it looks like we're coming close to wrapping up our time. So I'd like to ask you, we ask the same 3 questions of every guest on the show. The first of which is, can you recommend a resource, and it could be a book, website, podcast, anything related to feed manufacturing for our audience?
Yeah, so it might be a bit of a shameless plug because we're involved currently in the revision of it, but one of the best things out there continues to be the feed manufacturing technology textbook. It's generally not being, there we go. Yeah, right there on the shelf. It's not being published and printed in the book form, at least not right now anymore. But you can go through AFIA and you can get both a digital subscription and a printed subscription to that. And it's got kind of everything related to feed milling. And what we're going through right now is trying to find current authors in the industry, update chapters, certainly update regulatory parts of it. The whole idea, and it's, this is what I do for a living too, right? And it's on my shelf too. And Charles and I talk about that, Charles Stark being at K-State, and it's on all of our shelves because we still turn around and grab it and say, hold on, let me look through, and there's something in here. I remember where it's at. Let me go read it real quick again. As far as the one-stop shop to go find that stuff, I don't know that there's anything better out there than that. There's some other good websites. We did a pelleting handbook a few years ago. It's on Watt. You can basically look up Watt pelleting handbook. It's free. You just have to log in. You have to register, but then you can get in for free, and it's all about pelleting. That's out there. And then the other, podcasts like this, get a subscription to Feed Stuffs, Feed Strategy. Their Watt's now doing the Feed Mill of the Future. Some of those things that just kind of hit the inbox every day that can be really quick reads while you're still waking up and having coffee and whatnot. That it's like, oh, that's very interesting. I didn't know that was coming. So I think all those things are great. But as far as like a single resource to keep on the shelf to go look from, that FMT book's still the thing that comes to mind. And That's version 5. The online was kind of going to be version 6, although it's going to be continuously updated. But the first one was 1970 something. So
a lot of information.
it's been around for quite a while. So that's definitely a really good thing.
Awesome. I'm looking forward to that new edition coming out. I'm going to have to pick that up. As far as a book or resource outside your field, can you recommend something?
So I'm currently reading a book that I'm really enjoying. It's called, I might get the title wrong, but I'm going to try to get it right. I believe it's called Promises of Giants. It was written by a guy named John Amici, who was an NBA player for a long time. He's actually British. He's now a doctor of like clinical psychology and does a bunch of leadership work with companies and things like that. I found it to be a really cool book from a leadership perspective, and very different than some of the other like there. And not say that any of these aren't good, but the habits of effective people and who move my chi, that all feel a little bit like I'm being given like a leadership seminar.
Yeah.
This one has felt a little bit more like, okay, that's some interesting ways of looking things. And it's about, making promises kind of to yourself as someone who's going to be in charge, but also promises to the people, and really gets into this idea of how not to just make yourself effective, but how to make the people below you more effective. And so anything like that, really, I would say that's just the one that I'm currently read. And I will say this too, for people who are like, oh God, another one. The management and self-help, like that's not me. I don't read a lot of that. I'd much rather read, fiction, whether it be old, new, or whatever, when I'm on my own time. But someone recommended this one to me and I started reading it, and I've really enjoyed it. I think as many times, and Kate, I'm sure you've seen this plenty, as many times if I go into a facility or I'm talking to a group or whatnot, as much as we can talk about the stuff related to the equipment or the stuff related to the budget or whatever else, the places that are the most functional are the ones that are managed well. And the ones that are managed well are managed by people that know how to deal with themselves and people. Like if you know yourself and you can also manage the people below you and know when to push, but when to, give the kind word and how to evaluate them and all that, a lot of that other stuff can, stuff doesn't break as often because the maintenance guys are more than happy to be there and put in an extra shift because they want to get it done, because they have an invested interest in being there, because they like working there, because they like you as a manager, right? And all of a sudden I have less stuff break down, right? That's not because I had more budgets, because I have good people. When we do our for the AFIA 500 class that we do online, that Charles and I administer, that we do 4 times a year, there's a survey, and every student has to go survey a female manager. And we ask, what are 3 things you like and 3 things you don't like about their job? And I can tell you, almost every single response, one of the things I like about my job is I get to build a team and I get to work with good people. So putting in the work to also learn different strategies and stuff like that, I think is great. And that's the one that I'm reading right now. And like I said, I don't read a lot of those, but that one was recommended. Again, it's Promises of Giants by John Amici. And it's kind of fun to go through and read and think about, I hadn't thought about that, and I should look at myself that way. And, what I'm doing is reflected down into my employees. And when I'm overdoing it and overworked, and now they think they've got to overdo it and overworked, I think I've made things better because we're getting more done. And in fact, I've made them worse because I'm modeling behavior that's going to burn us all out. That doesn't benefit me or them. It's like, oh, that's a good point. So
very interesting. That's a great recommendation, especially for those of us looking for something in the leadership side that isn't, 5-minute manager again. So excellent. Well, you kind of touched on our last question. We usually ask our guests what characterizes a successful person in their mind. But given that you already kind of talked about leadership, and also because it's a new semester and a lot of your work is in teaching both students and industry professionals, I wanted to talk to you about, what do you think sets someone up for success in learning as a student?
So I tell this to our students all the time. And it, like you just said, it applies to adult learning and learning throughout your life as well. Focus on yourself, your strengths, what you can do. We have a lot of students that come to college, especially at a place like NC State, where the requirement to get in is kind of high, the GPA and everything else. But a lot of them are coming from school districts, rural school districts, where to get there, they they excelled and they exceeded. And now they got thrown into the ocean with a whole bunch of other people that did that too. And they can get a little depressed a month in, and the first exam comes out and they didn't ace it, and they weren't even in the top half of the class. And they're, oh my, I don't belong here. Nah, that's not true. It's not that you don't belong here. It's just a different environment. What can you do? What are you working on, right? The other thing I tell them, and look, and I'm not knocking it because I've gone through ag. I love ag, everything else. There are degrees and there are things that you do that are literally rocket science. I've got a extended family member who's here at NC State that's in nuclear physics. And you go over to his office for lunch and you look at the whiteboard and you just, I don't know what any of this is. All right, to do this, you have to be like, okay, you got to be a genius. Okay, that's fine. But in most of what we do and in most of the things that actually run the world, you got to work hard. Mm-hmm. It's not the students that excel the most and the people professionally that excel the most are the ones that figure out how to work hard. That doesn't mean work all the time. That doesn't mean burn yourself out trying to study or working 20 hours a day. Now, if you don't exercise and go find time to play and have a hobby and enjoy your family and whatever else, you're not going to be happy. You're not going to work, right? But it's much more about the students who work hard and figure out the way that they're going to be successful than just the ones that are smart. Because we see plenty that come in and when they walk in here based on their papers and based on talking to them, they're smart. They also know that about themselves and think they don't have to work all that hard. And then first chemistry test bites them because they thought, I got this. As where the student who didn't come up that, but they studied and they worked hard and they figured out, what was going to work best for them. And they got a good night's sleep the night before, whatever it is, they excel. And so I think for students, and I tell them this all the time, it's more about hard work and balancing your time and being a professional in whatever you're doing when it comes time to be one, than it is about, I'm not as smart as them or whatever. That's not what it's necessarily about. So that's what I think makes a successful student, someone who's going to be engaged and manage their time and work hard at what they do and do it in an intelligent way.
That's a great answer. And really, I've seen that reflected in both my time as a student and in my career. I mean, sometimes, honestly, I've learned so much more from my mistakes and my failures than any of my successes. And a lot of it is about that attitude towards, I'm still going to come to work the next day. I'm still going to work just as hard, even though things didn't work out the way I thought they were going to at the outset. So excellent answer. Well, Dr. Fahrenholz, thank you so much for coming on the Poultry Podcast Show. We appreciate the broad conversation we've had today about the future and the present, practical applications, all the way out to, our dreams about inline NIR. Thank you so much for all the information you shared, and I hope you have a great rest of your week.
All right. Thank you very much. I enjoyed doing it.
Thank you.